This kind of problem is called a difference quotient, and we have a function f of x equals x plus 4 over x minus 1. It can be a fraction, not a fraction. But if you're asked to evaluate and simplify f of a plus t minus f of a over t, there's a difference in the numerator, and t is ultimately the difference in the denominator. These problems are popular in pre-calculus classes and college algebra because in calculus, what you get is you get the definition of a derivative. So f prime of a, that's often how we write the derivative, is defined to be the limit as t goes to 0 of f of a plus t minus f of a over t. So you don't have to do that problem yet, but that problem is why this kind of problem, of course, calculus is all about derivatives. That's why this kind of problem is so common. So let's do this. If they had steps, it might be easier, but of course in calculus, they just give you this piece. So the first step, if you were doing it, is what is f of a plus t? You're plugging a plus t into the function, and it's a plus t plus 4 over a plus t minus 1. What's f of a? Well, that's pretty straightforward. You just plug an a in for x, a plus 4 over x minus 4. Now we'll plug those two pieces in, and then the simplification is kind of the big deal. So what do I have? I have a plus t plus 4 over a plus t minus 1 minus a plus 4 over x minus 1, all divided by t. Now, that might look like a huge muddled mess, but just realize you have the difference of two fractions here. If, like just as an aside, if you had 3/5 minus 2/7, what would you do? You'd get a common denominator by multiplying this by 5/5, multiplying this by 7/7, right? We're going to do exactly the same thing here. We're going to say, okay, I have this mess here, but what I really want is I want this to be combined. So I'm going to multiply the left thing by x minus 1. X minus 1 is a number. I just don't happen to know what it is. It's not like 7. Well, it is like 7. I just don't know what it is. So it's that times a plus t plus 4 over a plus t minus 1, right? Multiplying this by a clever 1 minus this thing here, a plus 4 over a, oops, I have a typo there, a minus 1, right? We're supposed to sub in for a. Okay, I need the same denominator, so this had better be multiplied by a plus t minus 1 over a plus t minus 1. There's going to be a t in the denominator everywhere. How do we combine these two things? Well, a word to the wise, right? I have a t in the denominator. Sometimes I'll just pull that out. Dividing by t is the same as multiplying by 1 over t. My denominator is going to be, both terms are going to have an x minus 1. I'm so sorry. I have an a minus 1 there, right? I have to get that common denominator. A minus 1 times a plus t minus 1. And then that term's going to have that term's going to have that. Think of it like the 35 here. Both of these will have 35 as a denominator. What are the numerators going to be? Over here, I'll have this times that. So I'm going to distribute the a to everything. A squared plus at plus 4a minus a minus t minus 4. A to everything minus 1 to everything. Minus, and I'll put big parentheses, a times everything over here, a squared, at minus a. Let's see, that's a plus 4, so we got plus 4a plus 4t minus 4, right? Okay, so now the nice thing about these problems is usually tons of stuff cancels. So I have, notice in the numerator, I have an a squared minus a squared. I have a minus 4 minus negative 4. Those cancel. Let's see, an at, a minus at. I have a 4a and I have a minus 4a. I have an a and I have a minus a. It seems like the only things that don't cancel is a minus t and a minus 4t. So really what I get is I get 1 over t and minus 5t over a minus 1, a plus t minus 1. Okay? Now, very predictably, almost always in these cases, you get a t in the denominator and a t in the numerator, so the last thing is to cancel those, and my end simplified answer will be negative 5 over a minus 1 times a plus t minus 1. There's a lot of algebra there, but the nice thing is once you have it, that definition of derivative is within reach.